In this video, we are solving a pair of logarithmic equations. So the first one here says log base 3 of x plus log base 3 of y equal to 0 and x plus y equal to 10 over 3. So to solve, now you will realize that this log can be removed. So we do have, first of all, we can write log 3. Since it is a product, a plus, we can use a product and we call this one xy equal to 0. We can take this 3 the other side, find the antilog, and we say that xy is equal to 3 power 0, and anything to power 0 is 1. So xy is equal to 1. So I'll call that one equation 1. We also have the given equation at x plus y is equal to 10 by 3. So we can now substitute from 1, x is equal to 1 over y. So I can substitute for y. So where there is x, I'm going to put 1 over y equal to 10 out of 3. So when I multiply x, y throughout, I get y squared. Then plus 1 equal to 10 y out of 3. So from here I can multiply by 3 throughout, I get 3y squared, then minus 10y plus 1 equal to 0. So now this is an quadratic equation which can be solved. So we have y equal to minus b, that is 10, plus or minus the square root of b squared, that is 100, minus 4ac, that is 4 times 3 times 1, which is minus 12. So we are looking at logarithm, and this time around we are solving simultaneous logarithmic equations. So we have 5 questions here, therefore. So we need to find the value of x and y in the pair of these equations, solving simultaneously. So in this first one, we will see log base 3 and even log base 3, but there is a plus, so we can write log xy, we multiply base 3 equal to 0. So now from here we can just find the antilog of base 3, or we take this log 3 the other side, we remain with xy, then the other one will be 3 power 0. This will be a base, and what we find there will be the power. So 3 to power 0 is 1. So that means that xy is equal to 1. I call that one equation 1. From the given equation, we have x plus y equal to 10 over 3. Let me call that one equation 2. So let us see now. From 1, we see that y is equal to 1 over x. So we can substitute in the second equation that x plus y, now y is 1 over x, equal to 10 over 3. Now let me multiply. I want to get rid of the denominator, so I can multiply with 3x. When I multiply with 3x, this one will become 3x squared. This just become 3. The other one will be 10x. We are multiplying with 3x throughout. So now this will be 3x squared minus 10x, then plus 3 equal to 0, a quadratic equation. So we can use the formula that x is equal to b minus b, that is 10, plus or minus the square root of b squared, that is 100, minus 4sc, 4 times 3 times 3, that is minus 36, then divided by 2a. 2a is 2 times 3, which is 6. So x is going to be equal to 10 plus the square root of 10 minus 36 is the square root of 64, which is 8. Then divided by 6. This gives us 18 out of 6, and we get a 3. That is 1x. The second x will be 10 minus 8 divided by 6, which is 2 over 6, and we get 1 out of 3. So these are two values of x. So from y equal to 1 over x, so y1 is going to be 1 over x1, which is 1 over 3, and y2 is going to be 1 over x2, which is 1 over 1 out of 3, and this is 3. So the solution set, we shall have the first pair, that is x to y. We shall get when x is 3, y is, when x is 3, y is 1 out of 3, and when x is 1 out of 3, y is 3. So that is the first part. Now let us look at part B. So part B, we have log base 2 and log base 2 here. These two can go on y there. So you may have log base 2x plus log base 2 of y squared equal to 3. Since this is the same base, I will write log base 2, then xy squared is equal to 3, then xy squared will be equal to, now we shall have, now this is log base 2, so if we have to remain with xy squared here, this 2 will be here as a base, then what we find there will be the power. So this is one equation. The other equation given is x squared plus y power 4 equal to 16. So now from 1 we can see that y squared is equal to 8, because 2 power 3 is 8, then over x. So we can substitute. It means that y to power 4 is 64 over x squared, because we square both sides to get y to power 4, and this will be 64, the other will be x squared. Now this gives us x squared plus 64 divided by x squared equaling to 16. Now I'm going to square, to multiply with x squared throughout, so this term will be now x to power 4 plus 64, then equal to 16 x squared. We bring the last term on the left hand side, we get x to power 4 plus 64 then minus, let me start with 16x squared. So we shall get negative 16x squared plus 64 equal to 0. We need to find now x, but now we can replace x squared with any other letter, let it be t. So we shall have t squared minus 16 t plus 64 equal to 0. And this is a perfect square. When you solve it, you get t minus 8 squared equal to 0. So that means that t is equal to 8, but t is x squared. So this implies that x squared is equal to 8. So x can be given as the square root of 8. So now we need to find y. So y can be got from any of the following. Let us see. Y squared is equal to 8 over x, meaning that y is equal to the square root, or we can even use, anyway, we can use this one here. Let us get x squared. Because we can use this. So x squared will be equal to 8. So we can use this one here such that we get y to power 4 equal to 64 out of 8. So y will be equal to, now 64 by 8 is 8, so it will be equal to the fourth root of 8. So the values of x to y, we have x as root 8, then y the fourth root of 8. That is the solution. Let us see part C. So for part C, we have log base x plus log x plus log y equal to 5. Now here you need to note that when you have the log and there is no number given down as a base, you know that is log base 10. But I want you to observe clearly. We have log x plus log y equal to 5. Now we could say xy is equal to 10 power 5, but it will not help us because when we look at what we have here, we cannot factorize out anything here. So but we can use a substitution. There is a log x which can be made a subject from the first one, and we substitute for it so that we remain with log y. Or we can use log y to make it the subject from the first equation, then we come and we substitute in the second equation. So from the first equation, you can see that log y is equal to 5 minus log x. So now since you have log y, we come to the second equation. Where there is log y, we shall put this. So we get 2 log x divided by 5 minus log x, then minus 3 log y divided by, no, log y we are going to substitute with 3. Now log y we shall put 5 so I have 3 log y, which is 3 into 5 minus log x, that is log y, then minus, no, over log x equal to 0, it is 1, equal to 1. So when we look at this, we can now create the same denominator. So when you get the LCM, we shall get 5 minus log x times log x, then here we shall get 2 log x times log x, then take away, this is going to be 15 minus 3 log x times 5 minus log x equal to 1. And now we can now put this on the right hand side, we cross multiply, but this gives us a 2 log squared x because this is log x times log x, so log squared x. Please don't put the 2 on x, the 2 should be in the log, or you could just put a bracket, you put the square out. So then minus, so we are going to multiply these two. 15 times 5, you get 75. Now 15 times negative log x, you get negative 15 log x. Then negative 3 log x times 5, you get negative 15 log x. And now negative 3 log x times negative log x, we shall get a plus log squared x, a plus 4 plus 3 log squared x, it is a plus 3 log squared x over, let's first multiply this, this is going to be 5 log x, then minus log squared x equal to a 1. Now let us see, inside the bracket, this is going to give us negative 30 log x, and now we have a positive, a plus, so let us write, this is going to be 2 log squared x, then minus 75. Now we have negative 15 log x, negative 15 log x, which is negative 30 log x, but there is a negative here, so it will be a plus 30 log x. Then we have 3 log squared x. This negative, make it a negative. So we shall have negative 3 log squared x over 5 log x minus log squared x equal to a 1. So now let's multiply. Now here we have 2 log squared x minus 3 log squared x. We get negative log squared x. Then minus 75 plus 30 log x equal to, then we have 5 log x, then minus log squared x. So now we can see that this log here, negative log squared x and negative log squared x cancels. So we are left with negative 75 plus 30 log x equal to 5 log x. Alright, so let us move to this side. So here we can take 75 negative 75 the other side and 5 log x this side. So we shall have 30 log x minus 5 log x equal to 75. So here we get 25 log x equal to 75. Okay, so now from here we see that log x is equal to 75 divided by 25, giving us 3. This is log x. So log x, x will be equal to 10 power 3 and x is going to be 1000. That is 1. We need to find x. Now we need to find y. Okay, now you need to recall that from here log y was 5 minus log x. So from log y equal to 5 minus log x, log y is equal to 5, log x is 3, so log y is equal to 2. So y is 10 power 2, which is 100. So the solution x to y is, we have x as 1000 and y as 100, and that is the solution for part C. Let us see the last part here. Now in this question we have log base 2 of x minus y equal to 5 minus log base 2 of x plus y. So I can rewrite it as log base 2 of x minus y equal to 5. Now we know that this is 1, log base 2 of 2 is 1, because I want to create a log on this constant here. So minus log base 2 of x plus y. So now we can see that this is going to be log base 2 x minus y equal to, now when this 5 goes this side, it will be 2 to power 5, and 2 to power 5 gives us, we get 32 here. So that is going to be log base 2 of 32, then minus log base 2 of x plus y. Now let me bring the x and y on the same side. So I get x, now log base 2 of x minus y plus log base 2 of x plus y equal to log base 2 of 32. So now you can see that this is a plus, so we can multiply them. And now this is, when you look at this is the difference of 2 square. So log base 2 of x minus y times x plus y is x squared minus y squared equal to log base 2 of 32. So now you can see that now since the base is the same, we can now see that x squared minus y squared is equal to 32. Now let us come down on the next in another equation. I have already simplified this. Now from equation 2, let me cross multiply. So I get log x minus log 4 equal to, now we are multiplying with a negative 1. So this will become a plus and this log y will be negative. So this will be log 3 minus log y. Now here we are dealing with the log base 10. So now the good thing here, we have log x, we have log y. Let me bring the letters on the same side and the numbers on the other side. So I'll just bring here and I say log x plus log y equal to log 3 plus log 4. So since it is a plus, this is the same as log xy equal to log 3 times 4. So we can see that xy is equal to 12. And now the new equations we have this and this. I have got rid of the logarithm. Now we can solve simultaneously. So now you will see that y is 12 out of x. Okay, so let me create some space here. We can now see that we have x squared minus, now y squared is going to be 144 over x squared, because we square both sides to get y squared, and now this will be 144, this will be x squared, so equal to 32. So if you multiply with x squared throughout, we get x to the power 4, then minus 144 minus 32 x squared equal to 0. So let me let p to be x squared. So we shall be having p squared minus 32p, then minus 144 equal to 0. So we can factorize this, or we can use a formula to get the value of p, but don't forget that p is x squared. So if we factorize this equation, we get p minus 36, then times p plus 4 equal to 0. I can then replace the x. So this is x squared minus 36, then x squared plus 4 equal to 0. Now we shall see that x squared is equal to 36, x is equal to 6. We shall not take a negative because we don't have a log of a negative number. Then again, when we talk about x squared to be equal to -4, then there is no solution for this. There is no real solution for this. So we are going to use x equal to 6. But now, what about y? What about y? We know we would have y equal to 12 over x. So our y will be to 12 over 6, which is a 2. So x to y, we have 6 to 2 as the solution. And that is the end of this video. This is question 6. We have one more question where we are still looking at solving simultaneous equation. So please try out these numbers for practice and prepare for your final exams. I am teacher James Isaac. Please, if you need some private coaching, it could be on Zoom or be one-on-one, physically, any means. If it is possible, you can reach me on this contact here, and we study mathematics. Thank you.